Alright folks, let's start with a simple but powerful idea. Who creates electromagnetic waves? Well, not a still charge that just sits there producing an electrostatic field, nothing exciting. And not even a steady current, because that makes a magnetic field, but one that just stays constant in time. So what's the magic ingredient? Acceleration. The moment a charge is accelerated, it starts radiating electromagnetic waves. Imagine pushing a swing back and forth. That back and forth oscillation is exactly like a charge oscillating with time. That oscillating charge becomes the very source of electromagnetic waves. Now here's where it gets even cooler. An oscillating charge produces an oscillating electric field in space. That electric field, in turn, produces an oscillating magnetic field. And the magnetic field regenerates an oscillating electric field. It's like two friends endlessly tossing a ball back and forth, keeping the game alive. This back and forth exchange means the fields can sustain each other while traveling through space, no wires, no medium required. The energy carried by these waves comes from the accelerated charge that started the whole process. So what decides the frequency of these electromagnetic waves? Very simple, it's the frequency of the charge's oscillation. If the charge wiggles back and forth 1,000 times per second, the electromagnetic wave also has a frequency of 1,000 Hertz. This is why high-frequency oscillations give rise to high-energy radiation like ultraviolet or X-rays. And lower-frequency oscillations give us radio waves. The wave simply inherits its frequency from its parent, the oscillating charge. Now you might be thinking, easy, let's just build a circuit where charges oscillate as fast as visible light, problem solved. But here's the catch. The frequency of yellow light is about 6 times 10 to the power 14 Hertz. Our modern AC circuits barely reach 10 to the power 11 Hertz, and that's already with cutting-edge electronics. So generating visible light directly from a circuit is practically impossible. That's why early experiments had to settle for much lower frequencies in the radio wave region. Sometimes physics reminds us that what seems simple in theory can be brutally hard in practice. And now comes the hero of the story, Heinrich Hertz. In 1887, he managed to generate and detect electromagnetic waves in the radio frequency range. He built a clever spark gap transmitter, and for the first time, humans saw Maxwell's predictions come true. Hertz showed that EM waves could reflect, refract, and interfere, behaving just like light. This experiment didn't just prove Maxwell right, it laid the foundation for radio, radar, and the entire wireless communication industry. Imagine, every Wi-Fi signal today owes a little thank you to Hertz's sparks. So let's tie it all together. Accelerated charges are the true sources of electromagnetic waves. Their oscillations create oscillating electric and magnetic fields which sustain each other and travel through space. The frequency of the wave is exactly the frequency of the source charge. Hertz's groundbreaking experiment in 1887 validated Maxwell's theory and opened the door to modern communication technologies. From radio broadcasts to your smartphone's 4G and 5G signals, it all started here. So next time you stream a song over Wi-Fi, remember, it's not magic, it's just charges dancing back and forth, creating waves that carry information through the air.